Good afternoon, sir. This is S. Nagarjuna. I am studying that BTech first semester in Department of Civil Engineering, Srinivasa Ramanujan Institute of Technology, Anantapur. Today, my video presentation on expression for pore pressure using Skempton pressure parameters by effective stress and pore pressure relations. Here, introduction of the Skempton derivation. Soil is subjected to external loading, undergoes changes in stress which affect pore water pressures. It means where the soil which is subjected to external loads like live loads from above the surface of the earth, which undergoes deformation and which affects the pore water pressure. Here, under drained conditions, Skemptons introduce parameters A and B to express the change in porous pore pressure delta U due to variation in total stress, that is delta sigma. Here the derivation which is derived by the Skempton, which is parameter based on parameters A and B. This is the A and B parameters are changing in pore pressure and variation in total stress. Here pore pressure is delta U and total stress is delta sigma. These parameters are widely used in geotechnical analysis of saturated soils. These parameters are which are useful for to determine the stresses of the saturated soils. Here, general relationship of the Skempton's equation. Skempton's equation: delta U is equal to B of delta sigma 3 plus A of sigma delta sigma 1 minus delta sigma 3 whole of, where A is the Skempton's pore pressure coefficient depending upon the stress path and soil type, where B is the coefficient of indicating the degree of saturation, 0 for dry, 1 for fully saturated. Here B is the parameter of the saturated soil, where 0 is the dry soil and 1 is the wet soil, that means fully saturated soil. Here delta sigma 1, delta sigma 2, delta sigma 3 are the principal stress changes. These are the changes of stresses: delta sigma 1, delta sigma 2, delta sigma 3. These are the parameters, abbreviations of this Skempton equation. For isotrophic loading, delta 1 is equal to delta sigma 1 is equal to delta sigma 2 is equal to delta sigma 3. And these are the, we assume that that the loading are all equal on the acting on the soil. Delta U is equal to B delta sigma 3. Here for derivative loading, pore pressure depends on the stresses difference, that is we determine the pore pressure on the soil for difference of the stresses, that is delta sigma 1 minus delta sigma 3. Combining both isotrophic and deviatoric components like yields, that is delta U is equal to B of delta sigma 3 plus A of delta sigma minus 1 minus delta sigma 3. Here the equation for the difference of the stresses between two. This account for both mean and deviatoric stress effects of pore pressure. Here physical meaning of parameters. The physical meaning of parameters is parameter B represents the degree of saturation. It means the degree of saturation of wet soil. For fully saturated soil, B is equal to 1. For dry soil is equal to 0. Here parameter A depending on the soil structure and stress path. It means where the type of soil structure like loosely grained, highly density grained, fully compacted soil, like that. Stress path means how the stress is going to the soil is acting to determine the path of the stress. Next, for normally consolidated clays is A is equal to 1. Normally the clays have 1. For over consolidated clay has may be negative. A may be negative. Next, the special cases of the parameters. First case is fully saturated, that is equal to B is equal to 1. The expression for the fully saturated of the soil is delta U is equal to delta sigma 3 plus A of delta sigma minus 1 delta sigma minus 3, that for fully saturated soil. Next, to dry soil, B is equal to 0. Here already know B is equal to 0 for dry soil, where delta U is equal to 0. Here B in delta in the place of sigmas we substitute the 0, the whole equation will be become 0. Isotrophic loading, here difference between the two loads are two stresses, that is become equal to one stress is equal to another. delta sigma 1 minus is equal to delta sigma 3. Here delta U is equal to V delta sigma 3. Alternative representation of the Skempton equations. Skempton equations can be also will be drawn will written in the terms of mean and deviated stresses, that is equal to delta U is equal to B of 1 by third of delta sigma 1 plus 2 delta sigma 3 of plus 3a minus 1 by 3, where delta sigma 1 minus delta sigma 3. This is the Skempton equations of the to determine the pore pressure of the soils for dry soil and wet saturated soil. This form of highlights in the contribution of the both mean normal stress and deviated stress to pore pressure generation. Next, final expression. The final expression of the pore pressure is the final Skempton pore pressure equation is delta U is equal to B of delta sigma 3 plus A of delta sigma minus 1 minus delta sigma 3. This is the equation of final Skempton pore pressure. Empirical and widely validated through triaxial testing. These Skempton equations, which are useful for triaxial shear strength of the soil in the laboratory test, essential for predicting undrained behavior in the clay and saturated soil. It is also for predicting the pore pressure for clay and saturated soil. Here applications for Skempton pore pressure is predicting pore pressure buildup during rapid loading, example embankment or dam constructions. These are mostly useful for construction fields like in dams to determine the underground pore pressures and stresses of the soils. Evaluating slope stability during undrained conditions. We determine the slope stability of the soil structures by the knowing of soil pores. Estimating short-term strength and deformation of saturated cohesive soils. Here to determine the short-term strengths like days of strength and determine the saturated cohesive soils. This is my presentation about on Skempton pore pressures. Thanking you this opportunity. Thank you, sir.